Imagine a vending machine. You put in a coin, press a button, and you get one specific snack. You never press the same button and get different things. That's what a function is. One input always gives exactly one output. In maths, a function is a rule that takes an input and gives back exactly one output. We write this as f of x. The letter f is just the name of the rule. X is whatever number we feed in. And the expression tells us what the rule does to the input. The simplest way to picture a function is with arrows. On the left, we have inputs. On the right, outputs. If each input sends one arrow to exactly one output, it is a function. But look here. Input 1 is confused. It's pointing to two different outputs. That breaks the rule. So this is not a function? Here is a neat trick. Hold a pencil vertically and slide it across the graph. If it touches the graph only once at every point, it's a function. The parabola passes. But look at this circle. When we slide the line across, it touches the circle in two places at once. That means one x value has two y values. So the circle fails the test. Think of a function like a machine in a factory. You feed in a number. The machine processes it. And out comes a result. Feed in a 3, and 2 times 3 plus 1 gives us 7. Feed in -1, and we get -1 out. Feed in 0, and out comes 1. Not every machine accepts every input. A blender can't blend rocks. The set of numbers you can feed in is the domain. The set of results is the range. Let's look at f of x equals x squared plus 3. First, the domain. Can we plug any real number into x squared? Yes. You can square -0 or positive numbers without breaking any math rules. Now, what about the range? Since squaring any real number always gives 0 or a positive result, x squared must be greater than or equal to 0. If we add 3 to both sides, we see that x squared plus 3 must be greater than or equal to 3. This means our function's output is always 3 or higher. So the range is y is greater than or equal to 3. Here we have a fraction. And in maths, we can never divide by 0. What makes the bottom 0? X equals 2. So x equals 2 is banned from the domain. You cannot take the square root of a negative number. So whatever is under the root must be 0 or positive. X minus 3 must be greater than or equal to 0. So x must be greater than or equal to 3. The domain is x greater than or equal to 3. And the square root only outputs positive numbers or 0. So the range is y greater than or equal to 0. Functions come in different types. Just like vehicles. Some are simple. Some are more complex. Let's meet the main ones. A linear function makes a straight line. It has the form x plus c, where m is the slope, representing a constant rate of change. A quadratic has an x squared term. Its graph is a smooth U-shape called a parabola, and it has a turning point called a vertex. A rational function is a fraction of polynomials. Because of the denominator, it has values it can never touch, creating gaps called asymptotes. Evaluating a function just means replace x with a number. and calculate. That's it. Let's practice. If f of x is 3x minus 5, find f of negative 2. Wherever you see x, put negative 2. 3 times negative 2 is negative 6. Minus 5 gives us negative 11. Next, for f of x equals x squared plus 1, find f of 3. Replace x with 3. 3 squared is 9. Plus 1 is 10. Finally, a fraction. Replace every x with 3. 3 plus 1 is 4, and 3 minus 2 is 1. 4 divided by 1 is 4. Notice the denominator isn't 0, so we are safe. Imagine you have 2 machines in a row. The first machine processes something, and its output goes straight into the second machine. That's a composite function, feeding the result of one function into another. F of g of x means, first apply g, then apply f to the result. Now replace x in f with the entire expression x squared minus 3. Expand and simplify. We get 2x squared minus 5. Now the other way round, first f, then g. Replace x in g with 2x plus 1, and square it. Expanding and simplifying gives 4x squared plus 4x minus 2. Look closely, f of g is not the same as g of f. They are different. The order matters. If we want a number instead of a formula, start from the inside. Find f of 2 first. F of 2 is 5. Now plug 5 into g. We get 22. Can you feed f into itself? Absolutely. One more for confidence with new functions. First apply k to 3. Then apply h to 9. We get 10. Question 1. Which set of ordered pairs is a function? Remember, each input must have only one output. The answer is B. Different inputs can share the same output. That's completely fine. Question 2. Evaluate f of negative 2 for 3x minus 5. The answer is C, negative 11. True or false? Every relation is a function. False. A function is a special, strict kind of relation. True or false? F of g is always equal to g of f. False again. We proved this earlier. The order matters. Finally, match the function type to its example. Linear connects to 2x plus 3. Quadratic connects to x squared minus 1. And rational connects to the fraction. Let's recap. 1. A function gives exactly one output per input. 2. Domain is the input. Range is the output. 3. Evaluating just means plugging in the number. 4. For composites, work from the inside out. 5. The order of composite functions matters. If you remember these 5 things, you have got functions covered. If this guide to functions helped you, please subscribe to Additional Maths Made Easy for more lessons.